now we're going to factor, okay, which is the reverse of that last set of sections. That's why I separated the videos. So, and then the second hour, we'll have to just look at the end of this. I told them. I yelled at them just like I yelled at you for not watching yesterday's video. Unless you didn't need to and you were perfect on the homework. That's fine. I know there are some people that are high flyers here doing quite well because of their Math 3 experience. And Math 2, actually. This is Math 2. Okay, now, I was one of those Math 2 teachers. I was. I remember teaching factoring. We first did GCF. Then after that, we did one method of factoring for all types of scenarios. But then at the end of that, I know I did, and I know all the rest of the teachers that I worked with did, you have to recognize some patterns to make factoring faster. You can't do that, break up the middle term, do grouping for every single situation, because the test will take you too long. There are certain things that that come out in certain questions that make unfoiling and undistributing very easy. So here are those patterns. One of these is kind of a formula that you are going to have to remember, but it works. I don't know if I have the time to prove it, but it does. And you just need to work on these next 2 days of figuring out these fast factoring patterns and really reach back in the accesses of your brain to figure out those. So I will say this first and foremost. This is always done first. You always look for, no matter what, a GCF. So every single question, this is no doubt 100% step one, or else you're causing yourself some problems in questions. No question about it. So what I put off to these words off to the side is just some basic questions. I think I did like 3 x to the third, y to the fourth, minus 9 x y to the seventh. I think it's different than the other hour. By the way, what is this? Binomial. You knew what I was asking. So there's only 2 terms. Now what you do from those 2 terms is take the numbers and the letters in order and figure out what the GCF is. What's a GCF between 3 and 9? What could be taken out of both of them? And the answer is 3. We'll divide that out here in a minute. Now look at the x's. X to the third and x. What could I take out of both of them? Only an x. That's the biggest I could take out of both of them. Nothing more. I can't take x squared out of the second one. There's not enough. What about y to the fourth and y to the seventh? Y to the fourth. Now again, I'm keeping it in binomials because we're just showing an idea, and hopefully that's enough for you to figure out what we need to know. Now what you need to do, what is this called? What? What have we undone? Not unfoiled, no way. It's undistributed. Okay, so we're undistributing this, so what we have to do is go back to each term and divide it by what we took out. What's 3 divided by 3? What's x to the third divided by x? X squared. What is y to the fourth divided by y to the fourth? 1, and this is why 1 times x squared times 1 is x squared. I don't write the 1s ever. Now, good distributors are good what? Factors, because all they do... stop. If I distribute 3x y to the fourth back to x squared, do you get 3x cubed y to the fourth? Yes or no? That's why I say good FOILers are good factors, good distributors are good factors, because they check. They don't write a nonsensical answer that doesn't match the distribution. So there's no reason to have a wrong answer here if you're a good FOILer and a good distributor. And then what happens when I take a 9 divided by 3? 3. And then what about when I take an x away from an x? 1. And then y to the 7th divided by y to the 4th? Y to the 3rd. And then if I threw this back in, 3 times 3 is 9, x, y to the 7th, you add those exponents. So the reason I say that is people that are good at factoring actually take a second to check, because usually distributing is easier than factoring. Now, this is a difference of 2 squares. Back when I taught Math 2, I had you do the long, convoluted, break up the middle term, even though there is not one, for this kind of question. By the way, the middle term is 0 here. I'm not done writing this. because this is a binomial, not a trinomial. So again, now the rest of these are these special factoring, and I might probably kind of skip around some of these. I'm going to skip some of difference of 2 cubes, do that at the end. So how does this factor? Well, this is the difference part, and then this is the 2 squares part. What's the perfect square of 9x squared? Well, then if I'm going to unfoil this, this must be 3x and 3x, because what's 3x times 3x? Good foilers. What's the perfect square of 16y to the 4th? 4y squared. And then let's just think of this in the terms of how do I get negative 16y to the 4th? One of these 4y squareds have to be what? Negative. I mean, that's another thing that drives me nuts about not getting the difference of 2 squares thing. When you unfoil, you at least better get the first and the last term. By the way, what happens to the middle term when it's plus and minus? It cancels. That's why this is the factoring of this difference of 2 squares. Hence, we have a very easy pattern. If I see a difference of 2 perfect squares, it's perfect square minus perfect square plus perfect square. Very simple, because the middle term always falls out. Now what I'm going to do is skip to the MA, I don't do tables. Okay, this is an ax squared plus bx plus c, where a is equal to 1, where you don't even see it. So this is the real simple question, and then this really comes down to numeracy as well. I did a real simple example last hour, same as you, but knowing how to multiply positives and negatives, and a negative times a negative is a positive, these are the things that trip people up in factoring. It's the simple, basic numeracies. You know, the ability to multiply and add. So I should unfoil this. Yeah, what equals x squared? What times what? X and x. Now, this is what I mean about MA, and I don't do any tables. The tables are the checking. I just do the checking in my head. Again, the teachers do tables great. What multiplies to 6 and adds to 5? 2 and 3. I heard a 6 and a 1. What's 6 plus 1? 7. 6 plus 1 does not add to 7. So you got to get a combination that satisfies both. Now watch. What's 2 times 3? Positive? 6. What's 3x plus 2x? 5x. The MA is making sure that you get that middle to work out. Now, I will go to, I only have 5 minutes. So again, you're about right where second hour was. I'm going to wait till we have an example of this. That's probably going to be on the video. So I won't show you it. And this is the way that you factored everything in Math 2 to start off with. When you break up the middle term and do grouping. I'll wait till we have grouping. When we look at the examples, I do want to cover, I only got to cover sum of 2 cubes with the other hour. So here's a sum of 2 cubes. And then I don't have the time to prove this. Maybe I'll prove it when I actually do the example. But don't get confused. This section says factor. So you have to write this in factored form. By the way, sum of 2 cubes. Do you remember? Now again, if this teacher didn't let you do FOIL, if they let you do SOAP, they're giving you a trick. Do you remember SOAP? No, who knows SOAP? I think I did this last year when we had cubes for trig. We factored cubes. Okay, what does S stand for? Same what? Same sign. But by the way, what's the perfect cube of A cubed? A. What's the perfect cube of B cubed? B. This is like a formula. What do I put in these two parentheses? A plus B. So I'm going to zoom in on this so we can really see this. And this should be enough space. So you put A plus B here. Then the next set of parentheses is a trinomial. Now, A times what? This may be a good approach to this. A times what is A cubed? So A squared has to go here. And then guess what? B times what here gives me B cubed? B squared. This is how you get the question. All right? And then, yeah, it's always positive here. It had to be anyway because b times b squared is positive b cubed. Then what goes in the middle? Well, what's O stand for? Opposite of plus. And then what goes in the middle here? The perfect cubes multiplied together. Now, this is what I don't have the time for. I proved a cubed plus b cubed. And I'm going to erase those things. What I didn't prove is all the rest of the terms what if I multiplied this out? Cancel. I'm not doing it. I don't have the time. Now, for video purposes, guess what if this was a difference of two cubes? What changes? This and this. Did I just blow your mind? That's the only thing that changes. Okay? Now, for you guys, you might have a little bit longer, but I'm going to factor fast. And then what can you do? Watch and rewatch. But as you put your stuff away, I'm going to go to the questions. By the way, what do you always look for first, no matter what? GCF. As you're putting your books away, what is the GCF of this first situation? YN. You yank it out. You take out a YN. What are you left with here? Come on, somebody. N squared. Minus, what are you left with? What are you left with here? Now, you're all proud of yourself. You're not listening. You better listen. All the questions you better look for factoring completely. Because yes, I pulled out a GCF, but is this factorable? And you should ask yourself that throughout your whole assignment. Is it or isn't it? What kind of factoring might happen? You made a mistake. What multiplies to positive 2 and adds to negative 3? Negative 2, negative 1, and you could reverse these if you wanted. So you must factor completely tonight. So after you do one set of factoring and feel good about it, check all the remaining factors and see if something can be done. Okay, and then I'm going to continue on. Hey, you'll be able to do this fast if you recognize your stuff. What is this? Difference of two squares. Perfect square of 64. 8 times 8 is 64, by the way. Perfect square of 25y squared. But it's got to be, one of them's got to be what to get negative 25 y squared? And then what happens to the middle term? There is no middle term. So I know this is the factoring correctly. Good foilers, good factors. I think we're exactly where the other hour was. Yep, I did not get to this one. We should always look for GCF. And as you walk out the door, you get to see this glorious math problem. Uh-oh, I have a question here. Okay, and yes, now that we pull out a 5, 5 times 25 is 125. Like I just said in the last question, and all of the stuff that we're doing, always check your factors and see if they're done. The perfect square of n to the fourth is n squared. Perfect square of 25 is 5. But it's more than that. How do you get a negative 25? It's got to be a positive and a negative. And of course, look at what happens with the middle term. It cancels. So, factored completely. Okay, I had sum of two cubes here. The perfect cube of y cubed is y. Perfect cube of 8 is 2. So remember SOAP for the trick for what are the signs on the binomial and trinomial. SOAP means same. And this has to be a y plus 2, the perfect cubes. And then just like I was expressing this before, how do you get y cubed? Y times what? Y squared. So it's the square of this that goes here. And then how do you get positive 8? You get it from these two being multiplied. So 2 times what is 8? 4, and it's got to be positive. I'm going to get rid of these lines then and show you the acronym. SOAP, same sign. O, AP, always positive is what that means for that acronym. So what's the O stand for now? Opposite of plus. And then what's the middle term? 2y. And that's a formula, I guess. But what happens with the middle terms is negative 2y squared and positive 2y squared. Those would cancel. 4y and negative 4y. Those would cancel. So all you'd be left with if you multiplied this out was, or is, y cubed plus 8. So that's why this all works out. All right, I don't think I have to explain that any further. I want to make the video at least a little bit fast, and then you do your own things. I guess I could add a harder example because it's another plus plus. But what you need to recognize is it's 1n squared plus 9n plus 14. So it is a MA situation. Then you're going to be like, oh, is it MA or AM? Which one's the M? Which one's the A? Good FOILers are good factors. You should know that this times this results in 14. So that is why that's the M number. That's what you're trying to create. And then these two numbers, when multiplied by O and I, give me the middle term. So whatever multiplies to 14 and adds to 9 is the magic of this. And by the way, n times n is n squared. Good FOILers, good factors. And you can write the 2 first and the 7 second. It doesn't really matter. 7 times 2 is 14. 2n and 7n is 9n. Factoring is actually not as hard as you make it. If it is hard for you. Oh, I actually should have something better than this. Some bigger numbers that are more challenging. But we'll see. This is a difference of 2 cubes. Because 1 times 1 times 1 equals 1. So this equals binomial, trinomial. So perfect cube of 1 is 1. Perfect cube of n cubed is n. 1 minus n. What goes here? Well, 1 times what is 1? 1. And the reason it's still 1, it is 1 squared that you put here for the formula, if you call it that. But that's still 1. Opposite of minus. And then these two multiplied together, not with the minus sign. It's 1n, or just n. And then always positive. Negative n times what is negative n cubed? And the answer is n squared. Negative n times n squared is negative n cubed. This is what I mean about checking as you this isn't unfoil, but unmultiply, I guess. So it all makes sense. And then again, like I said in that other example, 1n and negative 1n. Cancel. 1n squared and negative 1n squared. Cancel. So what's left is just 1 minus n cubed when you do 1 times 1 and negative n times n squared. Good FOILers, good factors, even though that's not at all a FOIL. Now we're down to, if you were worried about, I don't remember that even all of the factoring, we factored everything by this, MA method, but, busting up the middle term. Well, this question I purposely made challenging. What I've told my honor students back in the day was, you know what? Forget about methods. Actually, our old department chair never taught a trick for factoring. She said, hey, this is a trinomial, a quadratic trinomial. It should be able to, not all of them are, but should be able to be unfoiled. Just do it. So they had to guess and check and put numbers in. That's what I had to do back in the day when I was in high school, back when we wrote on stone tablets. But anyway, so here's the method that we've been waiting for. We now do not have a 1 in front of this. That complicates our lives massively. So what we got to do, if you remember, you should, is multiply 14 and negative 5. This is kind of a trick. 50 and 20, I feel like I'm making a mistake. I think that's negative 70. So the multiply number is negative 70. The add number is still flat out the middle number. And then I guess this is what a table is. You start guessing and checking what multiplies to negative 70 and adds to negative 33. And you guess and check 10 times negative 7. 10 plus negative 7 is not even close. Basically, it's this. Negative 35 times 2 equals negative 70. Negative 35 plus 2 equals negative 33. That's a rudimentary table. It's not really a table in the sense of how your other teachers may have taught you. I just want you to figure out the numbers. All right? So we got them. Now what do? Well, then that's where we did this thing. You take this middle term because you can, and split it up into, you know what, I'm going to do this the wrong way. Not the wrong way, the way that students, if they do this way, if they write 2y first and then minus 35y second, then you're causing yourself a little bit of heartache. And sometimes you don't have a choice to do this. So covering something on the grouping scenario. But back to this. This adds to negative 33. So this is equivalent to the previous step. That's important. All I did is rewrite this as a 4-term situation, equivalent to the previous step so that I can group. Remember, grouping requires 4 terms. Now, when I made the choice to make this minus 35y second, this creates a problem. Before you group, you should always make minus plus a negative and then group like this. Leaving that plus sign right there. Students that don't do this really cause themselves some harm. So if there was a minus sign in the middle, make it plus a negative and force yourself to group this with the plus sign on the outside there. Because now what I do is I look at each set of parentheses and find the individual GCF between just these two terms, which of course is 2y. You pull out 2y and then divide that out. That's 7y. 2y divided by 2y is not 0. Students do that all the time. Now the fact of me making this plus a negative proves, and hopefully definitely proves to you, that I should pull out a negative out of this parenthesis. And then the greatest common factor is 5, so you pull out a negative 5. And this is the magic in what has to happen for grouping. These two parentheses should be exactly the same, and they are. Negative 5 divided by negative 5 is 1. So, what's the final answer? What I've always told students is this. Put brackets around this and treat this as a term. And treat this as a term. What does term number 1 and term number 2 have in common? A 7y plus 1. You pull that 7y plus 1 out, and what you're left with is a 2y minus 5. And that is the factors that, well, wait, is it? Good FOILers are good factors. 7y times 2y, 14y squared. I'm going to tell you what happens so ridiculously. So ridiculously, when you get caught up in a method, your answer doesn't even make sense to the question. Like 7y times 2y, 14. Good. This is really where it goes wrong. You know you factored wrong if 1 times negative 5 does not equal negative 5. And that's usually the ridiculous answers I get. You get like crazy numbers that when multiplied together end up being 357, not negative 5. That just proves you don't understand the connection of foiling and factoring. So what I'm trying to hammer in your head over and over again is look at your answer at the end. Okay, we didn't really look at the middle term, but it does work. This is negative 35 plus 2y, which is negative 33y. Okay, whew, mouthfuls. All right, and then just like I said before, I think I might have a problem in this one. No, maybe I changed it. Trying to think of back in the day, did I have some issues with some of my examples? I think I'm good. So what's the common? This is grouping right off the bat. It's a brand new question. Pull out an n to the 4th, and you're left with n squared minus 3. Now, does this have a common term? And the answer to that is no. But what you should tell yourself is I could pull a 1 out in front so I know what happens next. Just like I said before, treat this as one term, treat this as a second term. What do these two terms have in common? That n squared minus 3. When I pull that n squared minus 3 out in front of this set of brackets, I'm left with n to the 4th plus 1. Now you should check, does anything factor? This is a difference of one square, but not a second square. This is sum of one cube, but not another cube. This is a perfect square, and this is a perfect square, but this is not a difference of two squares. So this does not factor anymore. Wanted to go through that just to make sure you understand, these issues. Okay, and that's not the assignment. Am I done? I guess I am done. Okay, so do your best to solidify that homework I'm going to assign you here.